to the public AI Cafe. Today we have the speaker Stefan Wellsandt from the Institute for Production and Logistic from BIBA in Bremen, Germany, here with this talk on applying digital assistance in manufacturing. And you also see the two co-moderators. It's me, Carmen, and Teresa from Grassroots Arts. Hello, and you also. Hello.
Hello, everyone.
And this cafe is part of the European research project, which is called AI4media. So always in the beginning, the rules, please take notice that the session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speaker expresses his personal view and opinion. This is not necessarily the official AI4media project opinion. And what's the cafe about? The cafe is an online forum to gain insight into the European AI scene. Participant gets the chance to share knowledge and experiences and meet stakeholders from various areas of AI research and application. And as always, welcome everybody coming to the cafe. It is very, very, very great to see you all here. And it's interactive, so if you have a question during the presentation, please write us, send us this question via this menu you see on the box. There's a menu, you can ask questions in the chat questions, and we try to ask them after the presentation to the speaker. And now to the highlights, to Stefan. Stefan Wellsandt works as a research scientist for the Institute for Production and Logistics, in short BIBA, in Bremen, Germany. He has 10 years of experience in international collaborative research on smart cities, the Internet of Things, product development, and data quality management. Since 2020, Stefan works on conversational AI in manufacturing after winning 2 EU-funded grants. His main project is COALA, which is a voice-enabled digital intelligent assistant for employees in industrial production. Stefan authored more than 30 academic publications and is an enthusiast of the ethical use of AI. Great to have you here. Hi, Stefan. I will make you now slowly the moderator, and then you can start and introduce what you are doing. And please, again, send us your questions before we start. I have to now make Stefan the moderator. Oh, it takes a moment. And we have to make it full
I think
screen.
It's my turn. Yeah. Sorry. Okay. So I think it's my turn now. Yes, thank you for having me here in the AI Cafe. First, I will say just very briefly something about my background, why I'm doing this presentation or where it comes from. So as you can see here, obviously on the slides, the presentation has to do with a project called COALA. That's cognitive assistant agile manufacturing for labor force supported by trustworthy artificial intelligence. And that's a project in innovation, research and innovation action. And we are building a digital assistant, a voice-based digital assistant for the manufacturing domain. And I'm going to tell you what we do in this project, what we learned so far also, what kind of problems we got. And for that, I have the following agenda. So I would say something about digital intelligent assistants, because I'm not sure if everyone is aware of what they are or how we see them. And then I say something about factories as workplaces, because I'm not sure that everyone is aware what that means. And then I will go into details about how assistants could support the workers in factories, the challenges, the disadvantages of such a solution, and limitations also. And then in the end, I will also say something about non-technical aspects related to this. So the application, of course, does not only mean that you apply technology in a place, you're also working with people. And then whenever you work with people, you need to do something that has nothing to do with the technology in this sense. So my own role in COALA is that I'm one of the two coordinators, and I'm at the same time also bit of a sometimes a developer even on the level of the assistant. So I take some hats from time to time that range from the management or coordination aspect down to the hands-on development part. Okay, the first thing, what is a digital intelligent assistant? Maybe you heard the concept in your home entertainment or home automation environment, Amazon Alexa, for instance, or Google Assistant. Those are digital assistants. There are other names also for this kind of technology, but we use the term digital intelligent assistant here. And one of its main characteristics is that it interacts through natural language. So you can talk to it in your language, either by voice or also typing. That's also natural language. Then digital assistants support or take over time-consuming, stressful, or otherwise unwanted activities. So they're really an assistant in this sense, and they know and do things that humans associate with intelligence. That's why they are in a more literal sense, they are artificial intelligence. So they do things similar to things that humans do, and that's why we perceive this piece of software as intelligent. And then they are at the same time something that I labeled as amorphous compound technology. That's a bit technical now, but what it means is that it's not so clear what a digital assistant can do, because that depends on what you load into the assistant. It's similar to a smartphone, so you can load different apps into it, skills, they are called skills in this case, and then it can do certain things. So it's not so clear what it can do in the first hand when you just hear about a digital intelligent assistant. And then they are compound technology. That means they constitute of a variety of technologies or software pieces that work together as one thing. And the face of that one thing is what you perceive as the assistant in the end. But of course, in the back end, there are significantly more complex things to consider, software parts to consider. And it is also so that in most cases, you will find not only one, but multiple AI-based components within a digital assistant. The illustration I have here is just to briefly outline how it technically works in principle. So you have a transcription part where you turn the speech into text, then you try to understand the text, then then the assistant uses that understanding to decide how to respond, and in that process it can trigger or query other information systems. So it asks them for specific pieces of information that the assistant doesn't have itself. And these systems then are connected to all the kind of assets that we have in an application domain, in this case manufacturing. So it's connected to machines, to analytics processes, to media, and many other things. And then the last step is to take that response that the assistant decided to use and turn it into speech. That's for the voice part to work. You need the two parts on the left-hand side. If you have a chatbot, then you would be okay to just have the text understanding and the deciding how to respond. So this is how it works. Then factories as workplaces. So I chose these images here to characterize a little bit how different factories can be and what it means to work in a factory. So first of all, if you look at the, say, lower right and lower middle, then you see it's quite narrow. So you don't have so much space to work there. At the same time, factories can be quite huge. So the picture here in the upper middle is a factory where you can walk quite a distance to come from one end to the other. Then you can imagine, because of all the machinery that works in a factory, it's very noisy, up to a level where you need to wear protection. So you need to protect your ears against the noise, and that makes it very difficult to use a voice assistant, of course. Then you have manual labor. So don't imagine a factory is something where nobody has to work because everything is done by machines automatically or by robots. That's not the case, or in most cases it's not the case. At the same time, you have different degrees of automation. So you see machines that do tasks and there's little human involvement. And increasingly so you find, of course, robots and even cobots now. So those robots that work with the human in the same area. So where humans and robots need to somehow share a space. So this is the environment where we are trying to work with a digital assistant, and where we want to learn how to apply them and what kind of problems come up. And now I'm going through a couple of small dialogue sequences. There are a couple of these slides here. The principle is that on the left-hand side, you see a characteristic of a manufacturing environment. Then in the middle, you see a sequence, a dialogue sequence that we implement in our assistant. And then on the right-hand side, you see a summary of the assistant's benefits. That comes from a paper we published last year. You can find a link here on the lower right side, and I will explain now a little bit what all these things mean. So one of the characteristics of manufacturing environments is that the people that work there need to have skills, and they acquire these skills via vocational and on-the-job training. That can take days, weeks, or typically also years. So it's very time consuming, and you can imagine with an aging workforce and not enough people that replace the aging workers, this can lead to a bottleneck of the workforce, and then you're looking for ways how to help workers get quickly into the job and make it also attractive to some extent. That's why we decided to give guidance through an assistant here. In this case, it's about a worker that asks how to repair a rupture of a thread. You can see that the assistant then gives kind of learning contents, what to do in this situation. There are a couple of knots that could be applied, for instance, to fix a certain kind of thread. And then you can have different media also. You can work with videos, you can work with text descriptions, and these things are, it depends on the user, on the worker, what is preferred on the one hand side, and also, of course, on the kind of question that the worker asks. So sometimes they need something that can only be expressed or explained with the video, and sometimes the text also works. And this is how guidance has to be handled very flexible. Then we need to consider that workers learn all the time. So there's continuous learning beyond the initial training they got. And that means that a digital assistant has to at least differentiate the new workers and the expert workers, because they will need to have different kinds of guidance, for instance, or other kinds of interactions, so tailored to their needs. And that means we need to somehow anticipate these dialogues. You see here an example for a novice asking for instruction that's stored in a checklist. And in this case, we break down the steps in the checklist up to a very fine-grained level. So such a checklist can easily have 100 individual small steps, and those steps are relevant for novices that don't have much experience with how to do certain activities. Then the same the kind of support we would like to provide to experts, with the difference that the expert knows a lot of steps already and has experience how to do them. So they might need a certain reminder from time to time, or they might need to have a kind of assistance in a sense that they perform a checklist without missing a certain step, and they are required to confirm that they completed a certain step. That can be relevant because in manufacturing, you can imagine, for quality reasons, you need to have assurance that somebody did something, and sometimes you take their word, and that is the kind of confirmation that you're looking for. So you see the expert, and for the expert, the task that was broken down into smaller instructions is now only one instruction. So only the upper part here is the part that consisted of several steps for the novice. Okay, and then in manufacturing, we have costly shift systems. So that means workers are somehow kept redundant, and that is necessary because humans experience fatigue and need recreation. An assistant doesn't, at least if you consider that you have batteries and so on charged. So that assumed, but it is always available to help you in certain situations. So even if a certain analyst in this case might have left the office, you can get some assistance from the assistant afterwards, but maybe it's not as good as what the analyst could do. So that depends really on the task, on the implementation, and this small sequence here is to illustrate simply that the assistant is also available when a human that could do the same, probably even better, is not. Then we have a couple of characteristics that are specific for information-intensive tasks in manufacturing. So there, workers need to access information about the environment, so the machines and the products produced by the machines, and also in a more abstract way, processes that happen that you cannot necessarily see because they are an abstract concept, but you can ask things from this about this process from the assistant. So that's one thing. And then time-consuming data processing and analysis are typical also. So you might have an interest in a specific kind of information, and in order to get that, you need to wait until a certain analysis is completed. You also need to consider that in manufacturing, you deal with a couple of information systems, and each of these systems may have its own user interface. So that ends up in a situation where you need to learn also about several user interfaces. And the last point that I want to mention here is that you can, or you interrupt your work and you delay tasks if you have to move to a suitable computer with the right software. In manufacturing, you don't necessarily find computers around the corner so easily. So it's very beneficial to have a mobile assistance in that case. So the illustration that you see here is characterizing central access. So that means that we have a couple of information systems in manufacturing, and the assistant is acting as a central access point, not the only one. So it's an alternative way of accessing the information system, but nevertheless, it is a kind of central access that workers or employees can use to interact with parts of certain information systems. And then these information systems themselves are connected to the machines in manufacturing to analyze their data or control them, or whatever is necessary. Then another aspect is that a digital assistant can be used via or in various ways. And there are two key dimensions here that I want to point out. The first one is you can change the way how you interact with the assistant. You can interact by voice only, by a mix of a voice and screen, or by screen only. And this is illustrated here with different devices that sometimes possess a screen, sometimes not. And also certain devices are meant to be stationary and some are meant to be mobile. So a smart speaker, for instance, is a stationary device, voice only. And what we in COALA are using for flexibility reasons is a tablet. So that would be a case where you can use voice and screen, and it's mobile. And each of these choices here allows you to benefit in certain ways from an assistant. Two important benefits for manufacturing are hands-free and eyes-free work. So imagine that you have workers that do inspections and they need their hands, and they also need to concentrate on the task. Then in these cases, smart rings or smart speakers might be applicable. Of course, you could also lay down a tablet somewhere and then only rely on the voice part here. That would also work. But the point is that you need to really look at the kind of assistance that you want to provide for a specific task, and then you will find a certain device type or a platform type where the assistant is running on. Now I want to go into a little bit of detail here about use cases that we cover in particular in COALA. And that is one of these cases is so-called augmented analytics. Augmented analytics means that we do data analytics, but with the help of natural language interfaces, for instance, to support workers, to support people that are not so native in working with data analytics tools, and give them an instrument to access this the benefits of analytics. So in this case, our assistant itself analyzes the data from the shop floor in one of its software components. Then it is possible to control the analytics process through the dialogues. And the assistant also is capable of explaining results in a sense of explainable AI to improve trustworthiness. So the user can then ask, why do you recommend a certain practice? What's the reason for that? And the assistant would then explain itself. The two examples I provided here are quite simple. So in one case, we are as a user, we ask for a forecast for the consumption of hydraulic fluid for a certain time period, and the assistant responds with a answer, including or instructing me when I have to refill so and so many liters of fluid by a certain date. In practice, this example is maybe not the best, because for that kind of an instruction, you could also have a notification system that simply warns you before the liquid is out and gives you a notification. So there wouldn't necessarily be a user triggering that process. But still, the notification could happen over the assistant. Then on the right-hand side, we have a support situation during an inspection where the worker needs to know about the status of certain workstation components. So where machinery is operating, and the machinery consists of various components, and you need to check which one's working, and probably even need to ask for specific parameters, measurements done for certain components. So the thing that you might realize here is also that the user addresses the workstation with a number, with a cryptic identifier. This turned out to be quite challenging, even though it's one of the very fundamental things that we need to do in manufacturing when we interact with manufacturing environments, because you cannot easily spell such a number without either making a mistake yourself or with the transcription component in the assistant making a mistake here. And then if only one number is wrong, or one alphanumeric here is wrong, then it doesn't work, or it works in a weird way that you talk about a different machine, and so it's very unreliable if you use voice. So that's why we, for instance, here work with QR codes that we are scanning before an interaction or during an interaction, and then fill in that part that that you see here in the utterance. We fill it in automatically from the QR code. That's much more reliable and changes the interaction only slightly. So that's why why it's important to see the whole picture here. So you cannot only assume that the user provides the input in this kind of a assistance situation. Then the second use case I want to point out here is the so-called cognitive assistance in COALA. That is a function that helps workers, experienced workers, typically to collect what they know through dialogues, and then we want to have the assistant that it is able to give advice based on that worker's experience. And it can adapt its advising behavior also if you have a novice, or if you have an intermediate or an expert, then it would moderate the the advices here. So they are sometimes more detailed, sometimes less detailed, and in general, we would like to capture knowledge also and store it in a way that we can transfer it to new workers in order to address this shortage of the workforce that I mentioned in the beginning of the presentation. Now the challenges. So one of the most obvious challenges that you will have in mind probably is how can you use a voice assistant in a noisy environment? And the answer is a little bit, how can the people in airports that are working close to planes work there and have communication among each other? The answer is there are commercial tools, commercial headsets, microphones that do that for you. So you don't have to reinvent the wheel here. You have commercial tools that you can buy. You see me here with a headset that that has an integrated microphone with noise filtering or noise filtering. It's at the same time it's protecting me against the noise in the environment. So I can really work in noisy places with this one, with these ear shells. And I can use the assistant here by connecting my tablet, which allows me to connect to the assistant, and the microphone, that's a Bluetooth microphone, so I can work with this. It has its limits, so up to a certain point, it really is not possible anymore to also use this situation. We had some trials, and the experience was somehow not so good in the extreme level, when you can hardly communicate as a human by voice. Then connectivity, also a problem in manufacturing. If you imagine that it's an environment with a lot of different kinds of interfering factors, metals all around you, concrete walls and so on. So here, in general, we need to decide, do we want to have certain functions on device, or do we allow the assistant to, or the solution to have off-device capabilities? And I created this table here to illustrate what kind of options we have and what it means for satisfying requirements. So the best solution somehow in this table is the internet. If you connect everything via internet, then you would be quite happy. You buy into a couple of other problems then. So this is set here at this point too, but you solve a couple of others, and the ones that you see here, they are quite well solved if you have internet connectivity and can run the service off device. Then you might want to run a service on the intranet, so within the company or within the factory. Then most things work well, but you can not benefit fully from access to live information because your intranet doesn't have them, maybe. And remote control also works within that network probably. And the last one is then the no net or offline functionalities that works in some areas, and in some it doesn't, and in some it doesn't work at all. So you cannot have live information if you have a fully on-device, like a disconnected device. You also cannot do remote control, probably. So that's just an overview. So you need to find trade-offs here, and these are not the only trade-offs that you will find. There are also security trade-offs. You need to consider maintainability and so on, cost also. Then privacy is another aspect, and that one now is one that we tried to address from the beginning on in COALA. You have a couple of influencing factors for privacy. First of all, you have the law. So the General Data Protection Regulation, that's the law. So you need to fulfill the law, of course. But since it's a comparably new law, it's not so clear how you address it in a satisfying way. Then you also need to consider that in factories you have workers' councils, as in many other companies, and you have worker unions. And they do not let you do everything that you would like to do as a maybe as a technology-driven person, for good reasons also. Then you need to communicate with them, of course, and explain to them what you are doing. what your assistant can do, how it works, how it interacts with the workers, what it expects to need from the workers in a sense of personal information. So there's a lot of need for communication here. And then you have also labor laws, and these labor laws may not allow you to monitor your workers or to monitor individual workers' performance, and that is then constraining what you can do with an assistant, or in general what you can do with digital tools, of course, in manufacturing. So what we did is we practice privacy by design. So from the first month on of COALA, we started to think what to do with personal data and how to minimize it, because for us in a project it's also a burden to have it, because we need to prepare a lot of things and consider a lot of things when we deal with personal data. So it's best if you can take it out. But at the same time, you would like to have it for certain functionalities, such as personalization of functions, simply greeting the user with a hello and then saying the name of the user. That would be already a use of personal data, and it would be a problem in some way that you need to address. Same for customized assistants. So if you you can work with pseudonyms here. So you don't need to use the real name of a person to realize this, but still you need a pseudonym somehow to differentiate one user from another. At least we haven't found any other approach how to do it. And then also in manufacturing, you might, or in companies probably in general, you might want to restrict the access to the assistant so that only your own employees can use it, or only employees with a certain right or role can use it. And for that, you also need at least a pseudonym. So you need to register those workers by name that are entitled to use the assistant, and those ones receive an ID, for instance, to use in the assistant. That's how we realize this part in COALA. But then there are some things that are much harder to decide and to control, and that has to do with the way the interface works. So in a natural language interface, you can in principle say anything to the assistant. You could tell the assistant that a certain coworker, and you name that coworker, did something or didn't do something, and then you have personal data in your assistant without maybe being able to get it out again. So what to do in these situations? Those are examples of what it means to apply it in that environment and what kind of problems you will face with this specific type of interface, so a natural language interface. And it's similar for ethics also. There are a couple of influencing factors in the corporate world. We have to deal with the balance of power. So there is the employee and there's the employer. And those two, they do not have the same power. The employer can fire the employee. So that's why the employee might be willing to do things that they are otherwise not willing to do. Also using tools against what they would actually prefer doing. So that's something to consider. Then we have the big field of bias in training data. And in our assistant, we have different kinds of training data. We have the training data that deal with the assistant in the narrow sense, so collecting example utterances from users and training our dialogue model. With these, for the transcription part, you will need training data. For the voice generation, you will need training data. And then also for anything that has to do with predicting the quality of products, of processes, of happening of other events in the manufacturing world, you also need training data from sensors, from measurement devices probably. And all of these can have biases. So it's very difficult to create a bias-free training data set. And then there's another problem. In manufactories, in factories, sorry, you will see certain kinds of imbalances, I would say. The most obvious one is the gender imbalance there. So you will typically find more people of one gender than the other. That can be males, Yeah, but there can also be females if you look into textile factories in countries. So that is a thing to consider also. So if you learn something from those users, then you will get a bias probably into your training data, and you need to deal with that. Doesn't necessarily mean that it turns into problems for the users themselves, but it has to be monitored and assessed, of course. There's also a kind of danger of loss of autonomy if you have an assistant that somehow works for you or thinks for you in certain situations. Then that means that you're giving up autonomy, but at the same time you're gaining free time. So that's also something to consider. And the next bigger thing is explainability. Also has to do with ethics, and is a highly needed function for AI-based tools. So you need to be capable of, or the tool itself needs to be capable of explaining why it came to a certain conclusion, why it recommended something, why it predicted something, why it classified you in a certain way. And that is sometimes easier and sometimes very, very difficult to achieve. So we are working here then very close to the state of the art, and for some problems there are simply no solutions yet. Yeah, so this is what I wanted to share here. And then for ethics, we tried to use the so-called Altai self-assessment approach on our solution. Altai is a kind of software tool that you can use to assess to what extent you're meeting trustworthiness criteria in your AI solution. And what you see here is the result that we achieved so far in February 2022, so quite new. And you can see here that in the privacy area we are quite good, while in others we are quite bad. So that's still something that we need to work on. We are 50% of the project is done, so we have some time to improve it, but it's not so easy sometimes to operationalize the questions provided in this tool and combine it with what we have as an assistant, as a software tool. So some questions seem very difficult to answer for us, or might be even not the right questions. And lastly, I want to say a few words about confidentiality. So here, this is a wide field. Again, you don't want to have business knowledge in training data, ideally, because that is not the clients, the end users might not like that. And there's also a chance of eavesdropping. That means someone listening into a conversation with the assistant. So how would you deal with these situations? What to do in these situations? That's something that we cannot answer right now, or we don't have satisfying answers. That's part of the learning process. So when you use an assistant, are there any incidents where somebody listened into something that they shouldn't? What can you do about this? Do you need to have technical measures? Do you need to have organizational measures? Or what is the right thing to do in these situations? Now a summary of disadvantages, some disadvantages and limitations. Again, I said inherent risk that workers lose their autonomy. This has to be considered. It's also a point that for getting a lot of the benefits, you would need internet connectivity. So having a completely capsuled offline solution is really not working in the sense of getting the most out of an assistant. It would be maybe similar to having a smartphone with only a very small number of apps that only work offline. That doesn't work for all people. So that's something to consider. Then producers in the distant future could become dependent on such assistants and also on the vendors of these assistants. So that's why it's important to look forward into technologies where that are interoperable, that can be replaced by or exchanged with another technology. So you're not getting into a vendor lock-in, for instance. There are also technological and design limits. understanding language. That is something that has to be accepted. We cannot solve every problem. This is a narrow AI solution. It's not meant to be general AI that can answer to any kind of question. So you cannot order a pizza with this bot. It's out of scope. And then there are also security risks, as with almost all software. You might run the risk of espionage by someone activating the microphone on your tablet or something like that, or corrupting the assistant's response system and then giving recommendations to workers that are problematic, could hurt a worker or could damage assets and so on. Yeah, last few slides. There are non-technical aspects to consider. One of the most important one is a training concept for new workers, or for workers to learn about the limitations, the challenges, and the risks of collaborating with digital assistants. In COALA, we prepare learning nuggets for this purpose that we integrate into the assistant. So it's possible also to learn something through the assistant, and also in a course, in a kind of training course tailored to new workers. And also on the management level, you will need some kind of an AI-focused change management process to reduce the skepticism in the manufacturing world, so that humans or that managers know what it means to work if their employees work with digital assistants or AI in a wider sense. Then I just want to briefly mention that in COALA, we are also building up a kind of task force for digital intelligent assistants. That's an open group of global experts interested in digital assistants, conversational AI, softbots in manufacturing. So the focus is on manufacturing. And we would like to discuss technological barriers, ways to remove them, and also operationalization of AI ethics. So learning more about this. You can sign up for this task force using the QR code on the right-hand side, also signing into our newsletter, or you can get in contact with us following the email address provided here. And that is everything that I have to share today. So thank you for your time, and please let me know the questions so I can provide some answers.
Yes, thank you, Stefan. It was very, very, very interesting. And I will ask a question. There are many from the audience, so I have just a short question. You said you used a tool to test yourself if your product will be trustworthy. This I saw from inside, no? The tool.
Yeah. Yes.
Yes. What is the issue which is most, what you think, what you have most to work on to make it trustworthy?
To make it trustworthy, I mean, I can go back a few slides if I'm still sharing. I don't know. Am I still sharing? Yeah.
Yes,
okay.
yes, yes.
Very good. So if you take this one here, then it's clearly the technical robustness and safety. So that is a big concern in manufacturing. Imagine that the assistant tells a worker to do something that, and the worker is not really aware of the danger, then they could get hurt, or things could get damaged. So there are a couple of things that we need to consider here. We need to look into what our training course, our training material needs to teach to workers to be aware of these problems. So that's one aspect. And then transparency is to some extent a problem, because we would like to share the training data, or to make the training data transparent. At the same time, if you want to run a business with the assistant, then you might not find it so wise to share the training data. So what to do in this case? I mean, we thought about open source, doing things open source to address this problem in this project, but the problem remains, of course, if you go outside of the project, you work with closed source, then you still need to somehow address that. So you could reveal it to the clients, but then is that enough? So I think these two things are probably the more difficult ones. For the other ones, we have a lot of ideas already how we can address them. In COALA, we also we are seeking legal guidance, legal support to answer these questions here for our project. And then, yeah, we will see how far we get with this.
Yes, thank you. Great to share share this with us. And Teresa, one question?
Yeah, I have a question from Jennifer. She's asking about the novice / distinction. The question is, how do you distinguish between expert user between a novice and an expert? Is it hard-coded or adaptive?
Right now, we're using hard-coded distinguishing. You would start with putting people into, say, boxes. So the expert box, the novice box, and the intermediate box. But then the assistant, and that's something that we are still working on, the assistant would be capable of understanding if it presented information to a certain user already, or how often a user performed certain kinds of activities, and then it could skip steps in the checklist. But that is a tricky thing because we are not allowed to monitor the workers so closely. So we cannot monitor their individual performance. So we can also not use that to derive their skill level. So it's a thing that we are still struggling with, but the answer is we are hard coding it right now.
Okay, so I'm taking over another question from the one is Sabri from Sabri Plana. Sorry for. Have you used a known cognitive system such as IBM Watson or Stanford Genie as basis for implementation? How comprehensive number of information sources training effort was the training of the assistant? In my experience, she says, in my experience with developing a programming assistant, the training effort was crucial for success.
Yeah. Yes. So there are two things here. One is we have a component called Cognitive Advisor. That's the thing that stores knowledge and is probably what is closer to what IBM Watson can already do. But then on the other hand, IBM Watson is a tool that is not so cheap to use, say it this way, at least to my understanding. And what we did is we built a kind of simple knowledge graph to store that that knowledge that users provide, like you saw in the example dialogue. That's one thing. Then what we use for the assistant to generate many of the other responses for many of the other functions is we are using a combined solution that relies on Rasa. Rasa is a chatbot framework, and relies on Mycroft. Mycroft is a voice assistant platform. So we combine both tools, and that is where the bulk of the language processing happens. Mm-hmm. So we are building training data in these tools, and then combine the tools to work together. And then in that process, we are also querying the knowledge base, the knowledge graph for specific information that users left there to share knowledge.
Okay, thank you. I think this was extensive. Teresa, you want to ask?
Yeah, we have a question from Irene. First of all, thank you for a very interesting presentation. And her question is if you can comment on the effort required to collect all the required knowledge to configure the assistant, and how much knowledge can be generic about manufacturing and how much is strongly dependent on the specific company.
Yeah, this is a very good question. It's a question that I have too, so I don't have an answer for that right now. I assume that, or from what I experienced so far, it seems that we can generalize some functions, some intents somehow can be generalized, and they are then dependent on specific vocabulary used by the end users, by the factories, for instance. I think that we at some point can come to a situation where we need to just collect these correct words, these terms such as component names, defect names, location names, and so on, for a specific manufacturing environment, and then the rest can stay the same. So that is what our current assessment is regarding this.
Okay, thank you. And I've right from the beginning there was a question: do you publish papers on this subject? That's from Norbert Jastroch. Where can you find these papers? He would be interested, for example, exemplifications of hybrid intelligence, the combination of human deductive intelligence with machine-based algorithm intelligence. So where are your papers?
Our papers are on our website, first of all. So like all good European projects, we have our deliverables, our videos, our academic papers on the website. So you will find them there. Beside that, we are also organizing for the second time this year then a workshop or a kind of session at the APMS conference. Those people that work in manufacturing probably know that conference. There we have a session about conversational AI or digital assistance in manufacturing. And there are a couple of papers, because we are not the only ones working on this topic. It's a bit difficult to see, but others work on the same or on a similar topic, but they don't say it's a digital assistant. They say, for instance, it's something else. So other terms like softbot or virtual assistant, virtual private assistant, and whatnot. So there's a heterogeneity here of the terms, and that makes it difficult to find papers about certain topics nowadays. And this one is certainly a domain where there is fragmented knowledge in the academic world, but there is knowledge, so papers.
Thank you. And Teresa?
Yeah, we have a question from Tony regarding the difficulty to formulate more complex requests without making mistakes, and on the other hand, that the voice assistant sometimes doesn't or sometimes makes mistakes by misunderstanding the question. And the question is, did you investigate these usability issues, or more generally, did you evaluate the worker's user experience?
We consider this, but we don't evaluate it fully yet. So we have some first studies about the usability here. In general, it is so that we believe that in a digital assistant, you must accept that the assistant misinterprets, misreads, or otherwise misunderstands the human. And that results in situations where the dialogue gets derailed. So you have a breakdown of the conversation, and you need to somehow repair that. So that's one approach how we deal with these problems. So we try to help the user when something happens and the assistant doesn't understand, that we do not leave the user with the answer, I don't understand. Yeah, but at the same time, you are offering ways out of the situation. So you are, for instance, presenting buttons to with the most likely intents that the bot considers for your utterance, what you said, or that you have other techniques. So one of my colleagues is working on the fallbacks here in particular. And then also when we have more complex queries, we work with RASA forms. So RASA offers a function that is in principle kind of form filling approach. So you are looking for certain entities in an utterance or filling certain slots, and unless those are filled already, it keeps asking you about these specific things. So that's how we are dealing with more complex queries. But to be honest, voice is not the best instrument if you have a very complicated and long query to a database. Then you probably are better of using a graphical interface or something else. So it has its limits. That's one of the limits of the interface here that you need to consider also.
Yes, I think there's Alessandro. Hi, Alessandro. The question is jumping on. Also about speech in noisy environments. Humans tend to shout if the environment is noisy, but the speech recognition system has probably been trained on normal voice. Does this cause problem? Could the agent simplify its dialogues to account for poor communication?
It's a good point. Certainly it can influence the way that the transcription works. We haven't specifically investigated that part. Yeah, we haven't investigated that part. I think that's the answer, but it's a good point. So I will take note of that, that we're considering shouting. I know that some of the consumer devices, they are capable of handling these kind of inputs much better. So you can change your voice. You can whisper, for instance, to an Alexa, and it responds with whispering itself. So these kind of usability improvements and also reliability improvements are certainly possible. But it's in our case, we're somewhat constrained by what can be done in a research project. So there are so many. I said in the beginning, it's a amorphous compound technology. That compound technology is so complex now that for a research project, it becomes difficult to resolve problems on all ends. So at some point, we simply need to say something will be certainly solved in the future. So someone else will solve the problem. It's not a satisfying answer from the point of an end user probably, or from someone that wants to use the technology now right from the shelf. But that is unfortunately, in my view, the answer for a research project.
Exactly, it's for the next research project. And the last question, and then we are out here.
Yeah. I think we have time for a last question. Again, thank you for this excellent presentation from Yves. And his question is how COALA could support collective work and cooperation between workers. And that's regarding not only sharing knowledge, but to combine knowledge and to address an unexpected situation together.
Yeah, I'm not so sure that COALA can really address that problem in its lifetime. The thing is, for the assistant to solve that problem, it would need to have access to a quite powerful knowledge processing system somehow. So probably something like an IBM Watson with a lot of training data inside, and or something similar. So for us, it will be difficult to implement such a thing in COALA. So the project was not designed in a way that we emphasize one part so much that we can solve a very big problem, like working with knowledge, deriving new knowledge, or even supporting this collaborative situation where several people contribute knowledge, and then you're deriving new knowledge from it. So that's probably something, again, for someone else, or for someone else's component, that we can then interact with via the assistant. So what the assistant technically does, it has a dialogue model that can, or that works for another software or for another software component that solves a very specific problem, like predicting something or like classifying something or like querying a database. So we have, in the narrow sense, the assistant has a dialogue model for these kind of things that we tailored, that we built, and but the bulk of the intelligence is then done by the other part, and that other part in this case probably has to be provided by someone else.
So thank you, Stefan. Thank you very much for all your very good answers, and secondly for your great presentation. You got a lot of compliments already from us and from all the participants.
Yes, thank you.
Was very clear and inspiring, and also new ideas for new research and projects, but also how to apply it right now. And so thank you, and I will send you, just that everybody listens, the recording, and of course you, Stefan, the speaker, will decide if it can be published or not. And if yes, then it will be on the usual AI-Cafe channels. And if you want to have the presentation, please send me an email or Stefan directly. There you see info@COALA H2020 EU or me. And then we might send you this presentation if, again, Stefan allows. So that's it. It's a typical AI-Cafe, and I'm very happy we're here. Come back next week, next Wednesday, and see you soon. Have a nice afternoon. Bye-bye.
Bye-bye. Thank you.
Thank you. Thank you.